Okay, it seems that we are at the top of the hour. So let's start without any further ado with the Gen AI primer for cyber tech. We'll probably by the end of the session try to discover the future of cybersecurity and what is the role of the Gen AI in it, if any. Before to start, I want to make acknowledgements and disclaimer page here. I have no affiliations with any of the vendors, product, program, services in this presentation. Where I do, I will definitely let you know. This is my own experience, my own views, and this session is not intended to provide any special advisories. The examples and the results shared are just my personal experience. So what are we going to talk today? We'll explore the general AI landscape to understand the context of generative AI within the larger AI framework. We'll delve into the operational dynamics and functionality of generative AI. We'll talk about analyzing the notable advantages and maybe limitations of Gen AI. Highlight some of the key scenarios where Gen AI has already demonstrated its power. And we'll work on the discussion of the crucial connection between the generative AI and the cybersecurity today in two different sections. One is leveraging Gen AI for cyber tech applications, what the vendors are producing today, where we are looking to apply it, how it's going to help us, and then how to ensure that our Gen AI deployments are secure, what strategies and measures to implement to safeguard the generative AI implementations. Now, if this looks very complicated, here is my promise to you. I won't go too geeky on you, and I will try to keep the conversations entertaining as much as possible. Assuming the picture that we have on this slide on the right, I will also try to keep the positive outlook as much as possible. So our life today and the AI role in it, it's way beyond the hype. We do have a prevalence of AI. Doesn't matter if this is the movie selection with Netflix, which is old, or the history when IBM won Jeopardy and Google Go won the chess and the game Go, or talking about new delivery systems with drones or the pizza delivery trucks with self-driving. We all have home assistants and smart appliances at home. Don't you hate when your refrigerator is smarter than you? I don't like it. But generally what we have today is kind of a circling around this figure in the middle, the chart in the middle, the AI applications, the learning systems, the AI enablers, and all the functionality within the circle. So this is where we are today with so-called classic, general, or sometimes called narrow AI. And here we have, in the end of last year, ChatGPT showed up, and suddenly Gen AI became very popular thanks to the offerings like the OpenAI's GPT, ChatGPT, and DALL-E program. The big tech companies have been very fast to jump on the bandwagon as well, with Google, Microsoft, Amazon, Meta, IBM with their What's Next platform, lining up their own generative AI tools, platforms, and services. Now, but since then, Gen AI has been the elephant in the room. And that's not the only article that I have seen titled this way. I wanted to bring your attention, though, to the word cloud on the bottom. Unfortunately, I've lost the source for it. This is somewhere from the beginning of this year, February or March this year. And it's very indicative of what people think and how people feel about Gen AI. So ChatGPT in purple automatically aligns with AI. Okay, that makes sense, right? And automatically aligns with bias, right? So first red signal. If you take a look at the blue color, generative, okay, we are generating new content, aligns with IP and ethics in people's minds. And these are all professionals who have been surveyed. In the red, context, understanding, and model. Very, very important. So people understand that the model is understanding, specifically for ChatGPT, this will be natural language processing. And the context is extremely important. So generative AI, in this case, is a type of artificial intelligence technology, which means automatically that this is a machine learning system capable of generating various outputs, text, images, audio, video, code, any other types you can think of. Usually that happens in response to a prompt by a user. And now that we have these generative AI models, we can freely incorporate them into various online tools, could be chatbots, to allow a greater integration for the users. They type the questions or instructions and they receive the output in a human-like, understandable response. So the emphasis here is on creating, generating new content based on previous training. And as you have seen, we are talking about training on billions, tens and hundreds of billions of elements for each of those models. Now, as every new technology, the adoption has raised a lot of considerations. The simple truth really is that we should be following the trusted AI principles, the same AI principles that we are still working today to solve and to make sure we are compliant for the general AI that we are using today. And of course, as any new technology or any technology just in principle, Gen AI must be transparent, ethical, and explainable. Now, let's define the artificial intelligence and the generative AI. Where does generative AI actually stand? This is a picture from ResearchGate. I publish my research there as well. I love this site. If you're not familiar with it, definitely go and visit it. A lot of good materials are constantly publishing there. And it's kind of presenting visually what the artificial intelligence is today. And I added some colors for you so we can outline the several different areas. Of course, the very first one is the machine learning. And as you can see, the machine learning comes with its subfields or sub areas. This will be the reinforcement learning, unsupervised learning, supervised learning, and of course, the deep learning. The deep learning is very important because it actually bridges to the neural networks, because it uses the neural networks. So the machine learning is a subfield of AI. As we already see on the graph, it allows computers to learn without being explicitly programmed. Machine learning algorithms are trained on data, and they can use that data to make predictions or decisions to make decisions. The deep learning is the important component which I mentioned. Again, it's a subset of the machine learning in this case. And it uses artificial intelligence, artificial and neural networks, ANN, you will see them abbreviated, to learn from the data. The deep learning algorithms are able to learn complex patterns and relationships within the data that we trained them. The neural network in yellow on this chart on the left side is actually easy to explain. It's named this way after our brain's neurons, or the way we communicate to process the information. Similarly, the neural network consists of interconnected nodes, also called neurons, that process and transmit data. This is kind of by design to imitate how our brain processing works. The nodes in the network take, process, and pass information to other nodes, forming a layer structure that defines its name. Think about maybe an example of teaching a computer to recognize animals. So the little neurons are going to be the small decision makers in this case. First, the system will have no absolutely knowledge, similar like tabula rasa in a baby. And then after we start feeding it with animal pictures, it will learn on its own. It will connect. And so the neurons in the first layer will see smaller elements, simple elements, let's say dots and lines. They're passing this data to the next layer will start concentrating on the shapes. And this way, with deeper layers, the deeper we go into the layers, the system would find more complex patterns until the last one is able to say, yes, this is a cat, or I'm 80% sure this is a cat. If there's a mistake, it learns, same exact way like we go to school. The more pictures it receives, it starts understanding and gets better into the recognition. This learning journey is called training. In this case, with the image data. So a neural network is like learning a journey for a computer, and understands things by breaking them down into simpler pieces, putting them together to make sense of the world. Very similar to just like we do. On this chart, we also have the robotics, the computer vision, and the natural language processing area as well, as part of the artificial intelligence. This is a slide that I just described to you, so I'm not going to talk specifically. This is for the people who may not be able to attend in person, so they can just read the details. Now, I do not like this slide at all. I was asked to make this slide specifically for a presentation and decided to include it here just for informational purposes. It's way too simplified to me. But the general or generative AI, what is the difference? It's the creativity. This is where the emphasis is. Creating a new content, personalizing the experience, solving complex problems. That's really what the value here comes. It comes at the cost. It comes at certain considerations, maybe biased, maybe unfair, maybe non-transparent. But some of the problems that we have with Gen AI are pretty much similar to what we have with a regular general AI today. So, as we discussed, we have the artificial intelligence as the outside frame. Then we have the machine learning with all of the different type of supervised, unsupervised, reinforced, the deep learning. And then as part of deep learning, we see generative AI and the large language models, the LLMs as well. And the data science, as you can see, cuts across all of those different layers. So I have an example here, very, very simple. What is the input? What is the model? And what is the output after the action? So in the general AI, we have a model that is based on learning relationship between label and data. That's why we have data and label as an input. We have traditional ML model, which is usually discriminated. The function will be classified, and then we're going to end up with a label. Okay, this is a cat. In the unstructured content, when the unstructured content is fed into the Gen AI model, it's a generative model. It's based on learning patterns in unstructured content. So it's a generation is the action, and we end up with new content. So now let's take a look at the next slide. This is the comparison of Gen AI and the classical AI. So from the input, we have a training code, we have a label data. Our question is an image of a cat. We build the traditional model, discriminative in this case, and the model, this is a prediction, classification, clustering model, which will come up with label, probability, discrete class, number. That will be the output it uses classic supervised and unsupervised learning. And the answer will be, yeah, this is a cat, or I'm 80% sure that this is a cat. The second example is the GenAI way. We have still supervised and unsupervised learning, but we also have a semi-supervised learning. We have the training code labeled and unlabeled data is the input. And the model will generate new context. So if I say, hey, an image of a cat, oh, here is an image of a cat, which is just created by me. Now, it can be blurry, it can be a futuristic cat, but it's still a cat, or what the model thinks is a cat. So the output here is going to be new content, and the new content can be natural language, text, image, video, audio, code, you name it. I think that this kind of makes it easy to understand. And if you have any questions, I'm happy to go back and answer some of them. With that, we can move to the next slide, which are the types of the GenAI models. Now, I apologize in advance. This is a very, very long and a very textual slide, although it's a visual representation of a couple of 6 of the types of the models that I wanted to talk to you about. The way this slide is organized is to give us a visual representation of the most popular types of GenAI, with a few examples of which the models actually are. And then I will also mention about the pros and cons of those models, the way we have them today. Now, one of the things that was very hard for me to do was to put, because on the right side, the description of the models is very, very short. And just to get the probabilistic graphic model of data distribution, for example, for the flow-based models, I had problems to kind of get it so short. Guess who helped me? ChatGPT. Yes, I said, okay, I want a shorter name of this for this. That's how I generated the definitions, the descriptions of the models here on this slide. So let's start with the transformer-based models. The transformer-based models, probably because ChatGPT is the one that kind of makes it fashionable. So now I would start with the more fashionable area. They use transformers architecture. This is a neural network architecture that is particularly well suited for natural language processing tasks. They're trained on large data sets to understand relationships between sequential information such as word and sentences. And although they excel in generating text, they can also generate images, other type of data, using so-called self-attention mechanisms. ChatGPT 3, Google Bard, and T5, again from Google model, are examples of the transformer-based generative AI models. The transformer-based models are very powerful, they're very versatile, and they can be useful for a wide variety of data. Now, they can be computationally intensive and expensive, I would say, expensive to train. And we have a less control over the quality of the data. The data can be repetitive, non-sensual, or sometimes even harmful. The second model is the GANs, the Generative Adversarial Networks. The GANs are type of generative model that uses 2 neural networks, same like the VAEs in the next line we're going to talk about. So the first is called generator and the second is called discriminator. And this is how they create the new data. The generator is responsible for creating a lot of data, while the discriminator is supposed to discriminate this data, meaning to distinguish between the real and the fake data. And that's the reason the GANs have produced a lot of realistic images, text, and music. They're able to generate very realistic data, which is really good. And specifically in like the image area, some really stunning images I have seen created. Now, on the negative side, on the cons, GANs can be difficult to train, and we have little control over the output. You're going to hear that quite a bit of me. They sometimes generate data that it's unrealistic and maybe sometimes even disturbing. Okay. DALL-E, Midjourney, ProGAN by NVIDIA, BigGAN by Google are some examples of the GAN-based generative AI models. And there are a lot of models, DCGAN, WGAN, a lot of others. The next line also uses two neural networks. By the way, it's kind of interesting. I was, I don't know what I was writing, like an essay or something. I was looking at the Google BART actually, and Google BART stated that VAs work on a single network, which is obviously a wrong fact. Just as a joke, just as an interesting fact. But the VAs variational autoencoders. They also work on two neural networks to interpret and generate data. In this case, we have an encoder and a decoder. The encoder takes the input data and compresses it into a simplified format. In the machine learning, we call this one latent space with latent variables. Then the decoder takes this latent representation and produces new data, similar, but of course not exactly the same. Here is an example. Creating human faces. Of course, we use photos for training data. The encoder will simplify the photos to the people's faces in a new important characteristics. That will be the size, the shape of the eyes, nose, mouth, ears, and so on. And then the decoder would use those to create, in different combinations, new faces. What are the pros? The pros is that the VAEs are relatively easy to train and they can generate high quality data. The cons is, again, this control of the output that we have. And not necessarily malicious data or harmful data. It can be unrealistic, it can be blurry, right? So the control of the data, the output. Some examples, I think I provided the VQVAE by DeepMind, the Pixel CNN++ from the Google AI side. And of course, there are others. The next group is autoregressive models. The autoregressive models are a type of generative models that generate data one step at a time. Each step, the models predict the next value in the sequence based on the values that have been already generated. Autoregressive models have been used to generate text, music, videos, and they're very easy to train, usually, and they can generate high quality data. However, they're slower compared to other models, and the quality of the data also need to be watched carefully. Pixel CNN is an example of autoregressive model that is specifically designed for, guess what? Image generation, pixel by pixel. Pixel CNN, it's intended to produce realistic images. The flow-based models is the next group, and flow-based models are not are a relatively new type of generative model, but they have shown a great promise for a variety of tasks, including image generation, text generation, anomaly detection. And this is one of the reasons why I wanted to bring them here to the conversation, assuming we're going to be talking about anomaly detection in cybersecurity a little bit later in the presentation. The flow-based models are a type of generative models that is used as probabilistic graph model to represent a data distribution. As the flow-based model continue to develop, I would expect to see them used much wider for a variety of applications. The main benefit is that they're very flexible and they're used to generate a wide variety of data. Now, obviously, they're going to be computationally expensive to train, which is a cons in this case, and they can sometimes have a low quality data in terms of maybe unrealistic or maybe disturbing. Okay. The last, actually, this concludes the unimodal models. And the next category is the multimodal model, which means that can understand and process multiple types of data simultaneously, such as text, image, audio, and to allow them to create more sophisticated outputs. As an example, might be that AI model is capable of generating an image based on a text prompt, as well as text description of an image prompt. DAL E2E and the OpenAI's ChatGPT-4 are examples of multimodals. The reason why multimodal models are not always included in the usual classification and presentations is because they're not well established as the unimodal models. However, as they continue to develop, they will likely become more widely used and accepted. And I would not be surprised if eventually they start replacing some of the unimodal models. I actually forgot to provide the examples for the flow-based models. There's so many of those. The Rio MVP developed by UC Berkeley, the GLOW and masked autoregressive flow are developed by the researchers in Google, NICE by University of Toronto, the inverse autoregressive flow is the OpenAI's equivalent as well. So there's a lot of information there, a lot of examples. I have not provided an example. We haven't spoken about the Meta's Llama, a large language model Meta AI. But this is an open source family of large language models released by Meta AI, starting, I think, somewhere in February this year. It is hosted on platforms like Hugging Face, and it's now most cloud providers you can run it. I saw instructions how to run it on Google Cloud. IBM said there was an article announcement that they will make it available as part of their Watson X platform as well. Really cool thing. Now, I slacked a little bit on this slide. I just saw a very nice article from the Tech Republic from August earlier this year, and I decided just to take a picture of their use cases, industry use cases. These are some of the areas when the Gen AI already has proven the applicability, it's proven its power. These are areas like healthcare, digital marketing, education, finance, environmental, areas where the Gen AI is one of the many tools within complex systems to actually provide additional value and to be an accelerator for the future program. Now, one thing that I was asked a couple of weeks ago, I was providing a consultation for a CEO of a Fortune 200 companies. And the question was, okay, well, I now have, up until the end of this year, I have provided my budget, and I have plans. I have already roadmap that we are executing going forward. I have some of the roadmaps stretching over next year. I've already planned the budget for it. I have deadlines that I need to deliver important things. So now are you telling me that I need to stop all of the work that I'm doing and start looking at what Gen AI can do for me? Should I replace all of those projects with Gen AI? And my question was no, absolutely not. You may want to review your roadmap and consider where the Gen AI can be an accelerator for you. But there are certain areas when the general AI or the narrow classical AI can even do better tasks if it's a specific predefined task. So it's all about to choose the tool for your business. What is the tool for the purpose, like we say. Now, although Gen AI and the bots are considered to be two different types of AI, usually, a combination of the two can be extremely powerful and can create extremely powerful and versatile chatbots. Now, I'm presenting a bot copy, just example of a bot. It's a highly intelligent bot. And we do a lot of cool stuff with Gen AI already. So come and check us out. Ding, ding, ding. This is an advertisement here. Yes, I'm on their board, and it's such a pleasure to incorporate the power of Google Dialogflow and a lot of other functionality that really discovers and supports a business value. Usually when we talk about bots and Gen AI, GANs are the models that are used to create the bots that are more engaging. They're more informative than the traditional chatbots. And so the main use case in this case is going to be create a more engaging chatbot, personalize the chatbot interaction. And the good part here is that these chatbots have the potential to revolutionize the way we interact with computers, with machines, but also to create a new ways of communication and collaboration, which is very, very important. Okay, so talking about the benefits of the Gen AI. And when we talk about that, we should always think about from the enterprise, from an organizational perspective, and also from human, our own consumer point of view. Of course, the companies are going to like, well, the improved productivity and efficiency with Gen AI brings by automation, freeing up people to do more strategic tasks, code generation, report writing, presentations creating, a lot of things that can be simplified. Of course, reducing of cost, better personalization and customization are going to be some of the other big business benefits. But as much as we go down, the increased creativity and innovation, the access to new resources, this is more human elements, but in the same time, these are big drivers for the business to enable the reduce of the cost, to improve the productivity, to improve the efficiency, and in some cases, change the way the businesses work today. So that's why I think this is extremely important. As pluses, we have minuses, and talking about limitations and concerns about Gen AI, I'm not even going to stop at things like hallucinations and stuff, because this is part of the technology, the evolution of the technology. We're well aware. You cannot take an answer like the Google Bart about the VAs last week, I think. So we would probably allude this to the maturing of the technology. But some of the items that are important are things like misinformation and disinformation, lack of quality control over the output. We definitely don't want our models or programs to spread false information, to damage reputation, to manipulate opinion. So, and this is, we need to realize that it comes based on the training data. So we are the one to train the model. We need to know what data we feed to the model. This also kind of comes to the copyright infringement point that is a little bit below. AI can be used to create content that infringes on copyright. I don't think that anybody is doing it purposely, but again, it's the awareness and to have some regulations of, hey, what is happening today? You see the strike of the Hollywood actors. This is exactly one of the reasons. Deepfakes is another problem, and not the deepfakes themselves, but it's actually the democratized way, the democratization. It takes a couple of clicks to create a malicious image that can potentially harm people and spread misinformation, right? Bias and fairness, digital privacy, digital trust. These are very important topics as well. We need to be prepared to handle those, to properly address those. We need regulations. We need to be treated in a way, the way we treat the quality of our code. They cannot be afterthought. That have to be implemented within the product when we design it and implement it. Regulatory challenges are some of these that I wanted to mention, because it's almost impossible to control the use of AI, if, for example, for malicious purposes, right? So we have the same safeguards like we do for any other product today. Job displacement, I left it here just because it was mentioned in most of the articles and kind of everybody talks about. I have the understanding that some jobs will be eliminated, like, for example, the elevator operator job was eliminated by having automated elevator. Other jobs will be created. And a lot of jobs will be changed the way they work. But we also have something that it's called advancement into technologies, which will make hopefully our life better, and we can concentrate on better things to do, on more valuable for our businesses tasks, which is why we always say that artificial intelligence of any kind, not just Gen AI, is not to replace, but to augment people's jobs and thinking. So let's talk about the cybersecurity, because this talk is said it's a primer, but it's a primer for the cybersecurity, cyber tech. So 2 quotes I have. We have generative AI is a dominating cybersecurity roadmaps and user events. Generative AI can provide a leap beyond how we apply the AI and ML today. Both very good articles, by the way. I provided the links for you here, one from VentureBeat and the other from Google Cloud blog. The first article on the left also has a great description of what all the vendors are doing today in terms of Gen AI. It's a great summary. I can't recommend it enough to you guys. But all the cybersecurity vendors today are basically have one common direction. They realize the potential of Gen AI and looking to form their vision on how they best can handle their customers and how to help them best and to accelerate their business. Most of those vendors today, they are already delivering features, products, looking to capitalize on the technology strengths, and all of them realize the Gen AI is a double-edged sword. And some of those vendors already have started to input safeguards into their products. So how can we leverage the Gen AI in cyber tech? Now, this slide, I had to fight with myself to make it so short, and it's still a lot of words on it. But there's so many good use cases that you can think. Think about improving existing AI-based tools or just regular tools, for example, automated patch management techniques, or maybe revolutionizing of XDR, automate the ML and analytic rules and SOAR playbook creation is possible. And by the way, the last one was provided to me as a feedback from one of my mentees. Thank you, Ishar. We also have detecting anomalies much faster based on a real-time information analysis, anomalies pattern in the real-time discovering, supporting post-breach forensics, a lot of things there, data reconstruction, anomaly detection, synthetic data creation for testing, malware and payload analysis, forensics evidence visualization. So a lot of things there. Data loss prevention, again, anomaly detection for insider threat, for example, content-aware data leakage detection, data anonymization and de-identification, intelligent content filtering and data reduction, NLP for policy enforcement, and so on and so on. Real-time risk assessment and quantification, which CISO or which board wouldn't want to have such available to them real-time. Prioritization, for example, triaging responses to incident responses and providing support to incident management activity and prioritization for that. Generating realistic attack simulations that we can use to prepare ourselves and to protect ourselves. Improving endpoint resiliency, self-healing capabilities, contextual intelligence. Big use case is attack surface reduction, anomaly detection, identifying and prioritizing which feature contribute most to the attack surface, network topology generations, And the last one I put here, just because lately I've been working on this, is enhancing the existing cryptographic discovery tools that can offer benefits, including improved cryptographic algorithms, intent identification, key detection, anomaly detection, etc. Now, this is a chart that I took from one of Google's latest reports. They're sharing how their AI red team helps to make AI safer. Some of the use cases, as you see on the slide, are prompt attacks, training data extraction, backdooring into the model, adversarial examples, data poisoning or exfiltration. It's a great article if you guys would like to go to read it, and show some of the real items and how Google actually handles those. It's a good article. So the good news here is that the old or our current security and privacy best practices still apply into the Gen AI space. Traditionally, our traditional models, like validation, sanitization of input, sanitization of input or output, they still apply. Many attacks of the AI systems can be detected in the same exact way as the traditional attacks. We still have to use the secure development environments to secure our training data sets, to secure the model itself. I mean, these are all things that we do today, one way or another. Now, there are some new things. Preparing for new types of attacks, prompt attacks, and content issues, as they may have, require multiple safety models to be applied. Sometimes when, let's say, the red team will discover something, and Google mentions that as well, and that's my experience as well, there's no easy fix. There's sometimes may not even be a fix. So you need to really look at some mitigation techniques. We need to start thinking about realistic end-to-end adversarial simulations and how we can simulate such in order to prepare, to be prepared. We definitely need to think about the ethical side, the responsible AI practical practices to handle ethical considerations and privacy concern, to prepare to monitor for adversarial ML techniques, data poisoning, model theft, model exploitation, and etc. So one slide that I was asked to add here is how to start with Gen AI. And I put a couple of steps: educate and train. This is a new technology. Like every new technology, you need to familiarize and to train your teams. Hire maybe specialists or get consultants that can help you to accelerate. Assess the use cases that you have and select good pilot projects for your initial projects. Make sure that your data is ready. Make sure that you have this cross-disciplinary collaboration, that you have these cross-functional teams from data scientists, domain experts, IT professionals that are there to support you. And of course, be prepared to handle the ethical considerations. And with that, in a nutshell, it's one of the most innovative technologies that we have seen embrace the innovation with Gen AI. That would be my first conclusion for this session. Gen AI is a huge promising frontier for cyber tech and a way to provide a new solution to old age challenges. Prepare for ethical exploration. It's crucial to navigate the ethical considerations and to have the regulations and the ethical considerations implemented within the product, not as afterthought. They have to be part of the design. Apply continuous learning. Embrace this culture of continuous learning. Things are changing so fast, especially into the Gen AI world. That's absolutely mandatory if we embark on this transformative journey into the cyber tech, and strive for the future possibilities. The sky is only the limit. Reshaping cybersecurity, harnessing the technology's potential for a safer digital realm is something that Gen AI is here to help us to do. And with that, I will want to thank you for joining this session. And let's see if we have some of the questions, maybe. Okay, I see that there's a couple of the announcements. Yes, you can follow me on LinkedIn. You're always welcome to message me with questions, comments. Appreciate the feedback. Feedback is always a gift. And of course, follow Clara's way to for other useful webinars like this one. In terms of the questions, do we have a model for discriminator as well? The answer is yes. Yeah, we would not have time today to go into the details, Irshad, about the different algorithms, but I would be happy to create a new session, to have a whole new session for discussions in them. Opinion on Gen AI in threat intelligence. So the Gen AI in threat intelligence, I want to add, I mentioned a little bit about that, but I want to mention another side that it's not very often outlined. Think about it this way. We usually search in our current threat detection tools and methods. We usually search for things that we know. And we usually want to be alerted of things that we may not know. And Gen AI is one of those excellent resources that will allow you to have a knowledge about things that we may not know, to search for something that we may not know. Definitely a huge future in the threat intelligence. And again, some of the vendors already are incorporating different models that are helping with that. So there's currently implementations. And actually, if you take a look at the first link that I recommended for you when I said that there's a lot of vendors, summary what these vendors are doing in this area, you'll find a lot of good information in this. Yes, so a prompt injection, Narayan, I see that you have a question about the prompt injection. It's something that we haven't had before, right? I mean, or maybe more limited. Now it's more prevalent. And it's something that needs to be handled. We need to be prepared. We need to, our developers need to be well aware, and we need to have test cases for this, for simulation, whatever that might be. So we make sure that we will address those. Okay, this is a good question. Can I recommend a course on SOC 1 analyst who is trying to keep up current on AI? I would assume that this one is done, you're asking about Gen AI. So, by the way, I don't know if you guys heard, but I think in the end of June 28th or something like that, there was an announcement that Microsoft has now a class, in LinkedIn, I believe, has a class. The class is free. Which is actually a primer for Gen AI. Google has a certification as well. It's I think completion certification, they call it. I took the class. It has an exam in the end. So I think that most of the vendors and of course some of the training facilities already have offering around that. But as you know, I'm a practitioner. So usually what I would say is, hey, don't just rely on reading about that. Try to get your hands dirty as much as you can and try to play. It's actually not that hard how you may think of. It's not that hard, and it's really really useful. By the way, that reminds me, I didn't make a comment, and I was thinking about that. Don't just think about as like business, from a business perspective. Think about from a personal perspective, from a consumer perspective. There's a lot of good articles on the Medium, and the PyTorch, I think, is another site. They provide advice to you how to more efficiently use ChatGPT, for example, how to form your prompts, how to provide the context so you can get better and more tailored responses to your questions. And I think that these are all the questions that we have. I think I answered all of those. And happy to go into all of the details that we may want to talk about different models, and actually to go into an exercise how we can implement a Gen AI for specific use cases. And if there's no other question, going back to the moderator. Thank you to Clara Sway as well for organizing the podcast. And looking forward to stay in touch.